Alright, ladies and gentlemen, so in this video we are going to start diving into how to find an inverse function algebraically. So that's our goal is. Now that we've gone ahead and figured out what one-to-one functions are, we've used the horizontal line test. Now the goal is to algebraically show the inverse of a function. And I've created some steps for us to think about. Step number 1, graph it on in your calculator. Use the horizontal line test to determine if it even has an inverse, all right? Then from there, we're going to replace f, g, h of x, etc. with y. You'll see why in a second. It makes our life easier. Third, we're going to switch x and y and resolve for y. Lastly, we're going to replace y with f inverse of x, and we can always kind of verify it with a composition just to double check that we are on the right track there. So let's first and foremost go ahead. I've gone ahead and graphed this one already, and hopefully we know this is just a linear function, so this does pass the horizontal line test there. So let's follow the other steps though. Okay, so from here we want to replace with y. It just makes our life easier than having to deal with f of x the entire time on through. So now once we've done that, step 3 says to switch x and y and then solve for y. So we're going to solve for y now. So I'm going to multiply by 2 on both sides. I need to get the y by itself, so I'm going to take 2x minus 5 and get negative 3y. And then lastly, I can see that y is going to be negative 2 over 3x plus 5 over 3. And so that's what we end up getting for our inverse function. Now, we can always go back and re-verify, but we want to make sure that we finish it off understanding the inverse looks little something like this. Okay? And once again, we can always check our work by verifying with the composition, substituting the inverse function into the original and seeing if we get x in return for it. All right, so I highly recommend pausing the video right now and seeing if you can answer these two on your own before we go on over them. So give it a shot. But let's take a look here, guys. Let's take a look at both of these. So step number 1 for the first one. All right, we're going to replace cube root x plus 1. Swap out the x and the y's. Now our goal is to resolve for y. We're going to have to cube both sides. And then lastly, we get x cubed minus 1 is what y is equal to. We want to finish it off with an inverse function of x cubed plus 1 in this example. Or x cubed minus 1, excuse me. Let me erase this here. X cubed minus 1 here. All right. So what about going for g? Now for number 2. Once again, y x cubed over 8. We want to swap out x and y and resolve for y. Multiplying, we get 8x equals y cubed. Cube root both sides. We see that y is equal to the cube root of 8x. Okay? And because we know that the cube root of 8 is 2, you may see this simplified on down times 2 cube root of x. We can go ahead and write that as an inverse as well. All right, guys? And so once again, don't forget that we can always go back and substitute the inverse into the original function and see if we do get that composition to equal x in the end. All right, guys? I've got one for you to try on your own. Give this one a shot. We'll go on over it first thing, and we're on to the next one.